Whereas a barometer is a device used to measure the absolute pressure, absolute atmospheric pressure, a manometer is a similar but different device in which one can compare the pressure of a gas within some sort of a vessel or apparatus to the atmospheric pressure and make a pressure measurement on the gas. For example, in this diagram it says apparatus, and let's just assume that this apparatus is a tank containing some gas. In this situation, this U-tube is the actual manometer, and you put mercury inside the U-tube, and if the pressure of the gas inside the apparatus is the same as the atmospheric pressure, then you would expect that the level of the mercury would be the same on both sides of the U-tube, because the pressure, the force, would be the same. It would be equalized. But in this case, what we see is that the level of the mercury is not equalized. On the apparatus side of the U-tube, the mercury level is higher than on the atmospheric side of the U-tube. And so what that tells us then is that the pressure exerted by the atmosphere is greater than the pressure exerted by the gas inside the device. And you can actually determine the pressure of the gas based on the difference between the barometric pressure, measured in millimeters of mercury, and the height, measured in the same unit. In this picture, imagine an apparatus containing a gas connected to this side of the U-tube and sealed here against that apparatus. In this case, this should be open to the atmosphere as well. The pressure from the atmosphere must be less than the pressure exerted by the apparatus, because the level of the mercury is lower on the apparatus side. So you can determine the pressure of the gas by comparing to the height difference with the pressure from the atmosphere that would be reported in some measurements such as millimeters of mercury. So it's going to be, the pressure of the gas is going to be less the height difference between the atmosphere and the gas side of the U-tube. And on this case, the pressure of the gas is going to be equal to the atmospheric pressure plus the height difference between the height of the side, atmosphere side, and the height on the gas side. This is a way to measure the gas pressure of some gas relative to the atmospheric pressure. So an example of this type of a measurement would be, what is the pressure in a system when the mercury level in the system side of the column of an open tube mercury manometer is 25 millimeters lower than the mercury level in the atmosphere side of a column, and the atmospheric pressure was measured from a barometer to be 760 millimeters of mercury. Well, this example where it says it's 25 millimeters lower on the apparatus side or the system side would be a situation like this, where the level is lower. That means that the pressure of the gas is greater than the atmospheric pressure. So we would use this simple little equation to calculate the pressure of this particular system, which is a gas, would equal the atmospheric pressure, which is 760 millimeters of mercury, plus the difference in height, which in this case is 25 millimeters of mercury. So the pressure of the gas then, in this case, is equal to 785 millimeters of mercury, which is the same as 785 torr.